Hi students, welcome to Mr. Bessling's first try-along YouTube video of the 2015 school year. I hope you are as excited as I am to go through this problem. So I just wanted to, this being your first video, I wanted to explain how these videos work. The idea is I take a long problem like this with lots of parts, and I work my way through it. Now the idea is that this problem is going to have a few different parts to it. In fact, it goes all the way up to part G. And the idea is every single time I start a new problem, I'd like you to really pause the video and try the problem yourself, and then listen to me work my way through the problem and hopefully explain it, and we can compare answers, and maybe you could pick up anything you learn. And this being a free country and all, you can pause the video whenever you want. You can rewind, fast forward, skip, pause, any of that. So I hope you enjoy this video. So let's get started on this problem. Alright, so a wildlife biologist counts the number of ducks at Round Pond every day at noon for 21 randomly selected days during the year with the following observations. So looks like one day it was 5 ducks at the pond and 8 and so on and so forth. So just to kind of go through all the problems that we're going to make here. We're going to, part A, make a dot plot of the data. B, find the 5-number summary. C, we're going to find the range in IQR. D, we're going to check for outliers using that 1.5 IQR rule. Part E, we're going to make a box plot of the data, including any outliers. Part F, we're going to calculate the mean and variance and standard deviation, and I'm going to go through both formulas. So I'm going to use formula number 1 and formula number 2 that we've learned. And lastly, I'm going to answer that question, would it be better to use the mean and standard deviation or median and IQR as measures of center and spread? And I'll explain my answer there. So let's get started. Let's waddle our way through this problem. Oh no, that was awful. Sorry, that joke always just quacks me up. Oh no, it's getting worse. Is this whole video going to be like this? Oh boy, yikes. You guys are committed now. You started the video, so... somebody's stealing a car. Okay. Alright, so part 1, we're going to make a dot plot of the data. And so to start out again with a dot plot, we kind of look at our values, our numbers there, our list, and we kind of want to know what our minimum and our maximum in it is. And I see my minimum looks like it's 4, my maximum is 15, and it's kind of nice to scale my my x-axis nicely here. So if I start at 4, I can start at 4, and I don't want to crowd this x-axis too much. I've seen a lot of dot plots where you write every single number. It's kind of cumbersome. It crowds it up. So if you see what I'm doing here, I'm just going by 2s. And I can go up to 16, the maximum looks like it's 15 in that set. I went one beyond. Oh well, that's life. So let's give this a title before we go on any further, or else you'll lose points on the test. Something like Ducks at Round Pond. Smashing little title. You'll love it. Alright, and now let's just go down the line here, making our dot plot. So I'm just going to go just right in order. So I'm going to start 5 gets a dot, then 8 gets a dot, and 8 gets, sorry, my stylus is a little harder to make dots. 8 gets, stop that. Sorry, not you, it's it was my stylus was giving me trouble. So let's put another dot at 8. Come on, there's a better looking dot. Okay, now I'm on 15. And then back to 5, and it looks like 4, and then a 6, then a 1, 2, 3 7s, so 1, 2, 3 7s, and another 6, and then a 10, and 2 more 6s. Yes. I get annoying because if I try to make too many dots, it's hard to explain. So there was the 9, I'm on the 5, 4, 6, 6, 7, 9, and 5. Where's 5? There's 5. Okay. So let's use these dots here to find the 5-number summary. And so when we do this, I can just use my dot plots. What's nice about the dot plot is I just took all those numbers and essentially put them in order. Because I know there's 2 4s, it looks like there's 4 5s, and 1 2 3 5 6s, and 4 7s. That is 4 observations that the duck found 7. Sorry, the biologist found 7 ducks at the pond. So let's, my 5-number summary is going to include my min, Q1, the median, the Q3, and the max. The min and max are pretty easy, right? 4 and 15, even though 15 definitely looks like it's a potential outlier, right? It is the max. So let's start with the median. We were given in the problem how many days? It said 21 randomly selected days, so I'm going to take it on face value and assume there's 21 numbers in there, which means the median should be in what spot in order? If I put all the numbers in order, all 21 numbers in order, what spot should the median be in? And in case you forget, we add 1 to 21 to get 22 and divide that in half, so that's 11, so it's going to be in the 11th spot. So I'm going to count my 11 dots. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That was my 11th dot. So that corresponds to the number 6. In other words, the median is 6 ducks, observing 6 ducks at Round Pond. So what the median does again is it splits my data into 50-50. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 less than the median, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 greater than the median. So I'm going to take the first 10, and I'm going to find the median now of those first 10 to find Q1. So that's 1, 2, 3, 4, 5, and 6. Since there were 10 numbers, where's my Q1? It's between the 5th and the 6th dot in this case, which is 5. And likewise, 1, 2, 3, 4, 5, it's between 5 and 6. There's Q3 right there at 8. Alright, it's exciting. Awesome. Okay, so let's find the range and the IQR. And the range, again, was just defined as the min of the minus the max. I'm sorry, the max minus the min, that is. And if we recall from our numbers, let's just go back to the 5-number summary. The max was 15 and the min was 4. So last time I checked, 15 minus 4 is 11. The IQR is, as we mentioned, this is going to be the Q3 minus Q1. And going back to my 5-number summary, my Q3 was 8 and my Q1 was 5. So my IQR is 3, and that represents the length of the inner quartile. The inner quartile, again, is the middle 50%, and we'll see that in the dot plot. I forgot to tell you to be pausing the video. Hopefully you're pausing it on your own, but let's try part D here. So pause this, see if you remember the 1.5 IQR rule. Okay, so for the 1.5 IQR rule, what we need to do is we need to calculate the following calculations here. Q1 minus 1.5 times the IQR, and also Q3 plus 1.5 IQR. So the top equation there, Q1 minus 1.5 IQR, is going to find any low outliers, values that are a lot less than everything else, and the bottom equation will find us high outliers that are higher than everything else. So see if you can, again, if you need a little bit of a push, see if you can try it now. Pause and see if you can find any outliers. Okay, Q1 was 5 and 1.5. We calculated the IQR before, it was 3. And I'm just going to put this in my calculator and figure it out. I'm going to pause my recording while I do it. And I got 0.5 here for this part. So what I'm looking for essentially right now is any numbers that, or in this case any observations of ducks less than 0.5. Of course it doesn't make sense to have a half of a duck, or well, hopefully it doesn't make sense to have a half of a duck at Round Pond. But obviously the smallest number of observations was 4, so there's since 4 is the minimum value is not less than 0.5, 4 is not an outlier. Let's try Q3 plus 1.58 IQR. So Q3 was 8, that was the third quartile, and times 1.5, the IQR was 3 again. We calculated that, and now if I put this in my calculator, I get 12.5. Okay, so let's see if there's any high outliers now, numbers greater than 12.5. Oh, there sure is. Here's 12.5 on my dot plot. There was my maximum 15. What does this mean? So since 15 is greater than 12.5, which again was Q3 plus 1.5 IQR, 15 in this context, ducks, is an outlier. So it looks like the biologist was there one day at noon. There was just a lot more ducks than usual, maybe something weird going on that day. Maybe there was a nice elderly man feeding a lot of bread to the ducks, and all the ducks got their friends together and waddled their way over to Round Pond. Oh man, here we go. Okay, part E. I know I had a lot of students ask me about making box plots. So pause it, try it, give it a shot. Okay, let's try to make this box plot here. And we're going to include any outliers. So let's start out with an axis, an x-axis, and again the minimum value was 4, it went up to 15, so I kind of like my scale that I had on the dot plot. I'll just kind of go by 2s, 10, 12, 14, and 16. And what was this? This was, and I forgot to do this on the other one, number of ducks. Write my variable here. And let's give it a title. Since I can, I'm going to use colors. I'll call it ducks. Ducks at Round Pond. Round Pond. Quack. Okay. Oh man. So the minimum value, I need my 5-number summary, and I also need outliers here. And here's where this is going to be just a little trickier because there is an outlier. My minimum value 4 was not an outlier. Q1, the median, and Q3 are always going to be there. My maximum value 15, however, was an outlier. It's going to get represented as a dot. And then if I look at my last observation before my outlier, that's going to be 10. That was going to be a day that the biologist counted 10 ducks at the pond. And 10 is not an outlier. If you recall, anything greater than 12.5 was an outlier. So what that essentially is going to mean when I make my whisker plot is that the last whisker is going to end at 10, but we're going to get a dot out there at 15 for the outlier. So let's go to my box plot. Again, my minimum was 4, not an outlier, no problem. My Q1 was 5. I'm just remembering these numbers now. The median was 6. Oh, sorry, that was my median. There's 5, and my Q3 was 8. Now, 15 I mentioned was an outlier, so it's going to get a dot. And what did I say my last value before 15 was? That wasn't an outlier? That's right, I heard you say it. 10. So what that's going to mean here is that my box plot's going to look like this. So just to circle and highlight and explain a few things about the dot plot. So this is my box plot, excuse me. This again was my min. This is Q1. That's my medium. This is Q3. Now technically this is my max out here, and this whisker is going to end at my, I don't want to call it the max, I'll call it the last value. That's not an outlier. And what this, how to read a box plot like this again is that, let's switch colors here. 25% of, in this case, the number of ducks at Round Pond in my observation lie between 4 and 5. 25% lie between 5 and 6. 25% lie between 6 and 8. And 25% lie between 8 and technically all the way out here to my max, because it does include my max. Alright, that was exciting, wasn't it? Okay, let's calculate x bar, s sub x, and the s sub x squared, excuse me, which was the variance, and the standard deviation is s sub x. I'm going to use Formula 1 here. I'm going to start using Formula 1, and if you want to try Formula 1, let's go ahead. But we need, our variance formula was 1 over n minus 1 times the sum of all my data points minus the mean quantity squared. So that really means step 1 here is I need to find the mean. And the easiest way to find the mean is I'm going to use my dot plot. Why? Because I know I had multiple repeats of numbers like 6 and 5, and it just gets really cumbersome to write 6 plus 6 plus 6 plus 6. You might have forgotten one, and then you have to go back and count and make sure you added enough 6s, and you know, you guys all know about the 3 types of people in the world, so it's better to use what I call the frequency approach to calculate the mean at something like this. And we have the dot plot here to help us. So I'm going to do this by going, all right, well, there was 2 observations where they witnessed 4 ducks. I got to go back to my dot plot because I forgot everything. There were 4 observations when they did 5. So if you want to try this, maybe you want to pause now. There was 4 times they did witness 5. There was 5 times they witnessed 6, right? 1, 2, 3, 4, 5, yep. 5 times they witnessed 6. There was 4 times they witnessed 7, and 2 times they witnessed 8. 4 times 7, 2 times 8. Oh man, I'm going to run out of room here. Can never write on these iPads, it's so small. 2 9s, 1 10, and 1 15. So, sorry, I have to kind of keep going here. 2 9s. That was a 9. 2 9s, I'm going to write it down here, plus 1 10 plus a 15. That was a 15 over there, I swear. And remember, there were 21 observations. They told us this. So, I could put this all in my calculator like it is, but you know what? Before I get there, why don't I just clean stuff up? I know what 2 times 4 is. That's 8. I know what 4 times 5 is. That's 20. I know 6 times 5. I know 4 times 7. I know 2 times 16. I know 2 times 9. I remember my multiplication table from back in the days, from the 1980s. Maybe it was the 2000s for you. And now I can put this easier in my calculator. So I'm going to pause the video and do that. So I got that the sum of x's was 145 divided by 21, which I got to equal 6.90. Not the prettiest number in the world, but you know what? That's life sometimes. So this is merely step 1 of using this first formula. So just so let's recall, x bar was 6.90. I'm going to erase all this. Bye-bye. I bet there's an easier way to erase all this. Here we go. I'll just circle it. And you don't know what I'm doing right now. It's okay. And cut. Some things got lost. in the process there, but that's okay. We know what we're doing. Okay, so now I'm going to spice this up a little bit because we have multiple frequencies. And here's how I'm going to do this. Minus the mean, and then minus the mean squared. So there was, let's go back to my dot plot. There was 2 4s. There's 2 4s. Actually, just use a different color. Why not? Okay, there was 2 4s. There were 4 5s. There were 5 6s. There were 4 7s. There were 2 8s. And 2 9s. And 1 10. And 1 15. So the mean here, if you prefer, was 6.9. So here's another way of looking at this. I'm going to take every number, subtract it by 6.9, and now what I'll do, I'm going to call the frequency f. What I'm going to do is I'm going to multiply by my frequencies. Just same thing as just adding multiple times, right? You know, let's see here. So my first data point is going to be 4 minus 6.9, so that's going to be negative 2.9. And what I'm going to do here is I'm going to do 2 times negative 2.9 squared. Why 2? Because there were 2 4s. You know, 4 minus 6.9 is 2.9, negative 2.9. So it doesn't matter how many times I do that. Next value, 5 minus 6.9 is negative 1.9. There were 4 5s, so I go like this, square it. 6 minus 6.9 is just negative 0.9, but there are 5 of those, so this is going to be 5 times 0.9 squared. Let's see, this 7 minus 6.9 is just positive 0.1, and there are 7 0.1 squareds. 8 minus 6.9 is 1.1, and there were 2 of those, 1.1 squared. Let's see, 9 minus 9.9 is going to be 2.1, and there was 2 of those, 2.1 squared. Oh, let's see here, 10 minus 6.9 is 3.1, and there was only 1 of those, so we're going to have 3.1 squared. And lastly, 15 minus 6.9 is 8.9, is that right? I'm going to double check that. And that's why I double check it, because I was wrong. It's not 8.9, it's 8. Yeah, you did it. 8.1, right? So this is going to be 8.1 squared. Okay, I'm going to add all these up. So I am going to take 2 times. I'm going to make sure I multiply. I'm going to multiply. So it would be 2 times 2.9 squared plus 4 times negative 1.9 squared plus 5 times negative 0.9 squared, etc., etc. I'm going to pause the video and do it. Hopefully you can too. Quick correction too, I made a slight mistake that I discovered as I was pausing the video and entering these numbers. I had a 7 over here where this red 4 is, and I meant to do 4 because there were 4 7s, not 7 4s. Okay, added all the numbers together and I got 135.81. So please pause it because I'm going to erase this screen. So what I got there is that the sum of all my data points minus the mean squared was 135.81. And if I recall, for the formula for the variance, I needed essentially just take this number and divide it by n minus 1. So n minus 1, there was 21 days, so I'm going to divide by 30, and I got 6.79. And now the variance is 6.79, so the standard deviation is going to be the square root of that, and I can put that on my calculator, and I get about 2.61. So this means on average the data, the number of observations of ducks at Round Pond have an average distance from the mean of about 2.6 ducks. That was kind of nasty, wasn't it? Yeah, I think so. Formula 2 might be easier. So if you want to use Formula 2, go for it. Let's do it. So if we remember, all we do is we take our values of x's, and I'm actually going to spice this up again here too, because we have frequencies. So here's what I'm going to do. I'm going to take my values of x, I'm going to square them, and then I'm going to multiply each by the frequency of each category. And maybe I'll even put my frequencies up here. For instance, let's go back to my dot plot. There was 2 4s. Let's do this here. So there are 2 4s, 4 6s, no 4 5s, 5 6s, 4 7s, 2 8s, 2 9s, 1 10, and 1 15. And actually, when I'm going to add up all my x's here, let me do this real quick. I am going to also multiply my frequencies here by the x's. I'm going to square my x's, and then I'm going to multiply by the frequency again, so I don't have to add all the time. So 2 times 4 is 8, 4 times 5 is 20, 30, 28, 16, 18, 10, 15. I'm going to add those all together. I get 145. Alright, so x again was 4, x squared is 16, 5 squared is 25, 36, 49, 64, 81, 100. Again, I'm just squaring my x's, not 125, 225. And now I'm going to multiply by the frequencies. Since there were 2 32s, there were 4 25s. Okay, I need my calculator for this. 36 times 5 is 180. 4 times 49 should be 196. Let me just double check that. It is 196. 2 times 64 is 128. 2 times 81 is 162. 100 times 1 is 100, and 225 times 1 is also 225. So I'm going to now add all these guys together, and after adding all these together, I get a smashing value of 1,123. Whew. I'm done, right? Oh no, I'm not, after all that work. So we're using the second formula when we take 1 over n minus 1 times the sum of the squares minus the sum, quantity squared, divided by n. I did all the dirty work. 21 minus 1 over here. The sum of the squares was that 1123 that we had calculated. And then we're going to subtract the sum of x squared. That was the 145 after we added them all together. And n was 21. So we have 1 divided by 20 times 1123 minus 145 squared divided by 21. And I got a whopping 6.09. And if I square, so this was the variance again, and now I should just have to square root this to get my standard deviation, and I get 2.46. Oh boy, if you watched the whole video so far, you recognize that I got a slightly different answer than I did using the first method. By using the first method. It looked like I made some kind of mistake, and I'm going to be honest, this this is way harder than you'll have to do on the test. The test, if I have you do this, it's not going to be such a gnarly list. It's not going to be 21 numbers. So I made some kind of mistake. I'm human. The values differ by just a little bit. If you recall my other in the other equation, I think I got 2.6 as the standard deviation, 2.61 or something like that. But I think if you watched the other part too, you'd recognize that this was a little easier to do, this method. And again, I won't have you do something this gnarly on the test. It'll be like a list of like 5 or 6 numbers tops. So, so still practice this. Oh man, throw me a bone here, people. Throw me a piece of bread at Round Pond or something. Okay, so this part G asks, would it be better to use the mean and standard deviation or the median and IQR as a measure of spread? And here's what we need to evaluate when we get this question. We need to ask ourselves, is this, it's a bad color, is this symmetric or is it skewed? Symmetric. If it's symmetric, we want to use the mean and standard deviation. But if it's skewed, or if there's outliers, we want to use the mean and IQR. Well, which one is it? Let's look. I think we already recall we calculated an outlier. And even though the distribution does look somewhat symmetric, kind of if we don't include the outlier, it's kind of symmetric. Once that outlier's in there, that is so far skewed, and you know the outlier tells it all. So it's skewed, it has outliers, so we want to use the median. We want to use the median and IQR since there are outliers. And why? The median and IQR are resistant, it's a word you need to know, to outliers. That is, let me underline that word or circle that word, resistant. You need to know that. They're resistant to outliers. They don't, the median and IQR don't change when there's outliers. Again, if you were in class when I did the house prices example, a measure of average or center, you know, the real estate agent should say the median home price is $350, and that's a much better representation of the average home price, because we know for sure 50% of houses are less than 50, and 50% are less than 50, and 50% are greater than 50. In the context of the duck problem here, what was the median? The median was 6, and if you recall, the mean I think was about 6.9, or it was 145 divided by 21, which 6.9. It's much more fair to say the average number of ducks at Round Pond is 6, the median, as opposed to 6.9, the mean, because that one outlier, the 15 observations, maybe it was the one day the elderly man was feeding all those ducks, that really kind of brought the mean higher. And if you really look, if we round that to 7, we have, like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations greater than 7, while 7 or greater, I should say, while nearly half were greater than the median. So the moral of the story is, if it's skewed or if there's outliers, we want to use the median and IQR because they're resistant to outliers. If the distribution's fairly symmetric, we use the mean and the standard deviation. And the reason why we use those is because they have much nicer mathematical properties than do the median and IQR. Oh boy, did you really listen to this the whole time? I spent 35 minutes on a Saturday morning with my little black cat. Well, he's not a little black cat, he's a big black cat right by my side. He hasn't really been saying anything, he's been quiet because I already fed him. If he was hungry, he'd be meowing at me and causing a ruckus right now. Alright guys, happy studying. I hope you found this video helpful, and feel free to leave any comments or give me any comments that you'd like. All right, guys. Have a great weekend. Happy studying.